These are the Unit 3 Module 2 notes on solving inequalities. Today we'll solve inequalities in one step, and we'll also solve two-step inequalities as well. We're going to take a look at our first example. It says 3x is less than 2. To solve this problem, the first thing we're going to do is similar to solving an equation, we want to get x by itself. So we're going to divide both sides of this inequality by 3. Here the 3's will cancel. We have an x. We're going to bring down this symbol, less than, and we're going to get 4 for an answer. X is less than 4. What this means is any number that's less than 4 should make this statement true. For example, pick a number smaller than 4, say 2. If I plug 2 in for x, I should get a true statement. Like 3 times 2 is less than 12. That means 6 is less than 12. That's true. Pick anything less than 4. Try 0. 3 times 0 is less than 12. That's true. 0 is less than 12. It checks out. I don't need to see that part. Basically, I just need to see the division step and then what we get for our final solution. So any number less than 4, x less than 4, makes this statement true. Same idea number 2. To solve this problem, we're just going to divide both sides of this inequality by 4. Doing so gets you x. Bring down the x is greater than or equal to. 20 divided by 4 is equal to 5. So that means if you pick any number 5 or bigger, it should make this statement true. If you try the number 5, for example, 4 times 5 is greater than or equal to 20. Yeah, 20 is equal to 20, so it makes the statement true. Pick something bigger than 5, like 6. If I do 4 times 6, 4 times x, if I choose 6 for x, 4 times 6 is 24. That is greater than or equal to 20, so I do have a correct answer. Things get a little strange, though, when you're dividing by a negative, which will happen in number 3. Here we're going to divide both sides by a negative 4. Doing so is going to get you what you might think to be t is greater than negative 2. If we want a number bigger than negative 2, try a positive number, like 3. When you actually do negative 4 times 3 is bigger than 8, what you get is negative 12 is bigger than 8, and that is definitely not a true statement. When you divide by a negative, dividing by a negative not only switches this 8 to a negative number, but dividing by negative also is going to flip this inequality. So instead of working with a greater than, we're actually going to work with a less than symbol. When you divide by a negative, you have to flip this inequality. So let's try a number that's smaller than negative 2, like negative 3. If you do negative 4 times negative 3, is that greater than 8? Well, negative 4 times negative 3 is 12. That's bigger than 8, so we get a true statement. The answer to this problem is t is less than negative 2. So just kind of a warning, if you're dividing by a negative, you have to switch the direction of the inequality. It sort of makes the inequality opposite of what it was before. So here we have negative 3m is less than or equal to negative 12. I'm dividing both sides of the inequality by negative 3. Because I'm dividing by a negative, the negative 3's will cancel. I'm going to get an m. Dividing by a negative switches this sign to a greater than or equal to problem. Negative 12 divided by negative 3 is 4. If you're unsure, pick a number that makes the statement true. Pick an m that's bigger than or equal to 4. Okay, let's try 8. 8's bigger than 4, so let me plug in 8 for m. Negative 3 times 8 is less than or equal to negative 12. Negative 3 times negative 8 is negative 24. That's definitely smaller than negative 12. Statement's true. There's your answer for number 4. Two-step inequalities also work similar to how equations worked earlier as well. In a problem like you have here, 2x minus 5 is less than 1. Our goal is to get x by itself. I see numbers on both sides, so let's get this 5 out of here. We're going to add 5 to both sides of our inequality. 5's cancel. You have a 2x on the left side, and you have a less than 6. To solve this, we divide both sides by 2. 2's cancel here. X is less than 3 is your answer. And then we're going to graph this like we did the other day by putting an open circle on our 3 value. Less than means we're going to move all the way to the left. And any point that's in the shaded region is a solution. For example, if you're like, let's try 0, you could do 2 times 0, which is 0, minus 5 is negative 5, is less than 1. That's a true statement. So if you actually plugged in 0, you could see, or any number less than 3, for example, you would end up with a true statement. If I try 0, I get negative 5 is less than 1. That's true. This works. There's your solution, and we have it graphed. What I'd like you to do is I'd like you to try out problems 6, 7, and 8. If you ever end up dividing by a negative, remember you need to switch the inequality. So I think that might happen in number 6. We'll have you pause the video for a moment, see if you can answer 6, 7, and 8. And when you unpause the video, we'll check our answers and see if your answers are correct. One thing before you start number 8, there is a typo in number 8 on some of your worksheets. There's an equal to sign here. This should actually say less than or equal to. So before you start on your problem, to make sure on problem 8 you change this inequality to a less than or equal to sign. So in problem 6, we're going to subtract 1 from each side of this inequality. By doing so, we get negative 3x on the left side. 1's cancel. We have a less than or equal to, and 10 minus 1 is 9. We're next going to divide both sides by negative 3 because we're dividing by a negative. The negatives will cancel on the left side. We get an x. Dividing by a negative is going to switch this inequality to a greater than or equal to, and 9 divided by negative 3 is negative 3. Here's our solution. When we graph it, we have a closed circle at negative 3. And we have an arrow moving to the right. To check our answer, pick some point in this region. I'm going to pick 0 actually because that's a nice value. I'm going to go negative 3 times 0 plus 1, and we're going to see if that's less than or equal to 10. Well, negative 3 times 0 is 0, 1 is just 1, and that is less than or equal to 10. That is a true statement, so our inequality probably is reasonable. On problem 7, same kind of idea. What we're going to do is we're going to add 3 to both sides. And we're going to get 4x is greater than or equal to 14. To solve this, we're going to divide both sides by 4. 4's cancel. You get x is greater than or equal to 14 fourths. That's also equivalent to the statement x is greater than or equal to 7 halves, or 3.5. So if you're looking at your graph for this statement in particular, we're going to go to where 3.5 is, some halfway between 3 and 4. I'm going to put a closed circle at 3.5 because it's a greater than or equal to problem, and we're going to shade to the right. To verify that our answer is correct, pick a point in the shaded region like 4. I'm going to plug 4 in for x and see what happens. So 4 times 4 minus 3 is greater than or equal to 11. Is that true? Well, yeah, 4 times 4 is 16, minus 3 is 13. 13 is greater than or equal to 11, so we have a true statement. This looks good. On number 8, some of your worksheets may have a typo. We're going to rewrite this as negative 2x plus 4 is less than or equal to 6. So there should be an inequality here. We don't want just an equal sign. We're going to make that a less than or equal to sign. To solve this problem, we're going to subtract 4 from each side. Doing so cancels out the 4's. On the left, you have negative 2x. You have a less than or equal to sign, and then this is a 6 minus 4, which is 2. To solve this, we'll divide both sides by negative 2. Negatives cancel over here. We have an x. Because we're dividing by a negative, this is going to switch to a greater than or equal to, and 2 divided by negative 2 is equal to negative 1. There's your solution. When we graph this, you're going to have your value at negative 1 over here. We're going to have a closed circle at negative 1, shading to the right. If your answer is valid, any point in this region should work. Let's take 2 this time. We've done 0 before. You can put 2 in if you want to. If you plug in 2 for x, you're going to get negative 2 times 2 plus 4 is less than or equal to 6. Well, negative 2 times 2 is negative 4, plus 4 is 0. 0 is less than or equal to 6. It works. So now you have an idea on how to solve our inequalities with one-step and two-step problems.